everybody. Welcome back to Master the NEC, where we talk about the National Electrical Code. Today's show is going to be a pretty special show to me because this is going to answer the question that I get on a frequent basis. Now, when I was an electrician out in the field and we had to do parallel applications, and the product of preference at that time was an MC cable. And so when I was designing the MC cable show today, and to be able to do that parallel application, I got to think about all those questions that I got about how come when I'm paralleling MC, and when I'm paralleling it, I have a larger overcurrent protected device than what I would have on a single cable, that the equipment grounding conductor is too small. And a lot of people want to blame the manufacturer. They want to say the manufacturer is making a product that's not compliant with the NEC because that equipment ground is too small if I run a parallel application. If you don't know what I'm talking about, then you've never run MC cable in a parallel application. And that's what today's show is all about, to explain to you why you have to take all those things into consideration when you're running that type of application and how it can be very confusing. So today we're going to talk about UL 1569, and we're going to talk about the requirements under 250.122 of the National Electrical Code. And so we're going to kind of talk about both of those, and I'm going to give you the perspective from the manufacturer, and I'm going to show you how it really works out to be fine when it comes to the NEC as well. But you got to remember up front, and this is important, the manufacturers of the products do not have to comply with the NEC. And it just so happens that the standard will harmonize so that they should both be compliant. In other words, if I construct it in accordance with UL 1569, which is for type MC cable, that it's still going to be compliant when it's used within the NEC. What's different is the UL standard is thinking about one single cable. It's not thinking about a parallel application. Whereas the NEC doesn't really say anything about the paralleling. It gives you guidelines for paralleling, and you have to make sure that you select a product that can meet the minimum safety standard of the National Electrical Code. So there's two different things going on, and you really have to separate the two. So before we even get started on it, let's talk a little bit about the UL standard. So if you've ever wondered when you see type MC cable, what standard is used to create that product? Well, as manufacturers, we design that product in accordance with UL 1569. And UL 1569 is a standard that tells us everything from its construction, of the thickness and the width of the armor. It tells us how you twist the conductors that are cabled. It tells you what those twists have to be per foot. It tells you about the binding material that holds those cables together. All these type of things are covered under the UL 1569. And one of the more important aspects of it is that it tells us what type of conductors that can be used in the process of making an MC cable, whether it's thermoplastic products under UL 83 or it's thermoset type of wire under a UL 44. And that is what the type MC standard for UL 1569 is going to tell us. And one of the other key things is it's going to tell us the size of the equipment grounding conductor. And that is the minimum size for construction, not for the NEC. It's for the construction of a single cable. So that's another thing that people, again, overlook. When you go with paralleling and you're doing cables in parallel and you buy an off-the-shelf cable, remember, we don't take into account anything to do with paralleling in the UL 1569. We only take into aspects of producing the cable itself. We'll leave the paralleling aspects and the sizing of the conductors beyond that point. We'll leave that to the NEC and the end user and the AHJ. So under the manufacturer's guidance, one of the aspects that we're going to look at is section 6.1.5 of the UL standard. And basically we're talking about the interlocked type of armor because that's the most commonly used type of MC. Of course, you have what's called smooth and you have what's called corrugated, and then you have what's interlocked. Interlocked by far outsells any of these smooth or corrugated type products. So we're going to stick with the interlocked. Now 6.1.5 says, and I'll read it, it says cable having interlocked armor not intended for use as a grounding path or ground path, and that's true because we're not dealing with a interlock that has that aluminum grounding / bonding conductor in it that touches all the convolutions and the outside armor becomes an effective ground fault current path. That's not what we're talking about. That's in healthcare facility applications or our smart ground products, some more advanced type of MC. Here we're talking about traditional type MC cable with the interlock. That means that armor is not intended for a grounding path. Sure, you got to bond it, all in accordance with Article 250. But for all intents and purposes, it's not designed to be a grounding path. Okay? So, normal interlocked armor. So, here's what the code says, or the standard says. It says, that type of interlocked armor shall contain one copper, aluminum, or copper-clad aluminum grounding conductor that is in one location or in several sections. So what does that mean? Well, I could take an equipment grounding conductor and size it, and you'll see here it's going to be sized based on some tables within UL 1569 as a minimum. I can size it to be sized based on that, or I can section it within that cable, maybe have 3 that are together would be the right size based on the table. But individually they might be smaller, but you bring them together at the end, and that's called sectioning. And the standard allows for that, okay? So when we're dealing with the main equipment grounding conductor inside of an MC cable, that is fine. Now, if I have an MC cable that has 2 equipment grounds in it, maybe one is the intended equipment ground, and then you have an additional equipment ground, you can section the main one, but you can't section an additional ground. The other aspect to remember is, under the standard, is if I have more than one equipment ground in there, the original one or the intended one can be bare or insulated, but the additional one is got to be insulated. So that's some of the things that you'll find in 6.1.5. But I guess the most important part that I want to read to you is that when we size the equipment grounding conductor, it's based on this. It says it can be one location, that is the full size, or in several sections that are not smaller than indicated under the heading grounding conductor in table 6.1 or 6.3 if we're dealing with 90-degree insulated conductors, which is generally what you're going to see in an MC cable. It's probably going to be THHN/THWN-2. So it's 90 degrees rated wet or dry. But if it was 75-degree rated conductors in the product, then you would use table 6.2 or 6.4. Now these tables, depending on what their usage are, one is for cables and one is for individual conductor inside of an armor, which might have an individual equipment grounded conductor inside of an armor. The 6.1 for the 90 is going to be a general cable, and that's what we're generally going to use. Or if it's a 75 degree, we're going to use table 6.2. Those are the 2 main tables that we're going to use. Now, for all intents and purposes, all of our conductors are 90 degree rated. So you might terminate them on a 75 degree terminal based on the limitations of 110.14c of the NEC. But at the end of the day, the insulation is going to be 90 degrees. So that's where the UL standard stays. It doesn't deal with the overcurrent protective device like the NEC does. It simply stays with the size of the conductors, the rating of the conductors, and the table will tell us what is the minimum size equipment grounding conductor that it has to be. All right. Now, it goes on to say one or more additional. Okay, now we're talking about the additional one, not the intended one. The additional, it says one or more additional copper, aluminum, or copper-clad aluminum grounding conductors may be provided. So that tells us that I can have more than one, and that stands to reason, right? If I have an isolated ground, I might have a equipment ground in there, and then I might need an additional equipment ground, which would be an isolated ground. So the code does, or the standard, if you will, does allow for this application to have more than one. That's not a big deal. Now, you also have to make sure that you meet the wet or dry rating. So whether it's if it's a THHN/THWN-2 insulation, and you got to have an insulated equipment grounding conductor, or that's your choice, then it also has to match the environment. Okay, that's your choice in that application. So that's all that's basically saying if you insulate it. Now, each additional grounding conductor shall not be sectioned. So what did that mean? We could section the original or the intended equipment ground, but the additional equipment ground, like maybe say the isolated ground, cannot be sectioned. All right, you can only section the original. Now, it goes on to also say that it can't be sectioned and shall not be smaller than indicated in table 6.1 or 6.2. All right, so you got to keep keep that in mind. It can't be smaller than that, and it can't be sectioned. Okay, now, if you don't want to section it, then both of the equipment grounds can't be smaller than what's in those tables. Okay, so there's your options there. Now, it goes on to say, look, if you only use one equipment ground, one grounding conductor is provided, it can be bare or it may be insulated in accordance with 400.1. So a lot of people ask me that question. They say, in an MC cable, does the equipment grounding conductor have to be insulated? Well, the additional one does, but the original one doesn't. It can be bare or insulated. Totally the manufacturer's choice on how they want to provide that. And in some cases, you can order it either bare or insulated. It's totally up to you. Personally, I like insulated because it adds that extra level of protection to the actual conductor. But again, preference is how you choose it as a contractor, how you want to order it. Now, if more than one grounding conductor is provided, all right, so we talked about the one. Now we're saying we're having a choice for more than one. Then the required one or the original one, that one may be bare or insulated. But then the other equipment grounding conductors, or the grounding conductors as the standard says, has to be insulated. So that's kind of redundant what we just said earlier, but that's kind of want to give you an idea of how UL 1569 functions, how it works. Okay. Now, when you're looking at these tables, now we talked about it earlier, you have table 6.1, and this says, the heading says, the smallest acceptable grounding conductor in cable containing 90° C circuit conductors. So, in our cables, if it's a 90° circuit conductors, that would be the THHN/THWN-2 or an XHHW-2 application, then we're going to size our equipment grounding conductor based on the requirements here under table 6.1, because those are 90° C rated insulated conductors. We are not going to care about the overcurrent device at this point. That's an NEC requirement. That is not a UL 1569 requirement. So let's take it one further. Let's say we're going to create some 3/0 MC cable. The conductors are copper and they're 3/0. What size equipment ground would we have to have? We're talking about a single cable now. Well, basically you go down the column, it's table 6.1, and it says 3/0 through 250 kc mil requires a size 4 copper equipment grounding conductor. All right, so that is what you're going to see in the product. We're going to give you 3/0 conductors, and we're going to give you a 4 equipment grounding conductor, and that's what you're going to get. And that's the minimum standard here for 90° insulated conductors. Now, if it was 75° rated conductors that are in there, slightly different. If it's 75° rated conductors, the same 3/0 only requires a 6 equipment grounding conductor because it's 75° C rated conductors. So again, whether or not they're 90 or 75 is going to be the key factor on what's our size of our equipment grounding conductor. Okay, that's the key. Now remember, none of this has anything to do with the NEC. This only has everything to do with the UL standard. Okay, so that's what you're going to get. So now let's skip forward and let's start talking about the NEC a little bit, because the NEC is the document that we're going to look at and see, all right, well, how does this apply to the NEC? Well, if you're familiar with table 250.122 of the National Electrical Code, you'll see that traditionally the equipment grounding conductor is based on whatever the size is of the overcurrent protective device ahead of the equipment or the conductors or the circuit, whatever. So whatever's up front is going to protect the conductors downstream. So if we had a 200 amp overcurrent protected device, then we're going to require, by the NEC, we're going to have a 6 AWG equipment grounding conductor. Okay, now, as you can see with us, if we decide it's on 90, then we're going to put a 4 in there, whereas the NEC says it only has to be a 6 for this application. However, you have to understand that when we base something based on the 90° C, that the UL is assuming that you could use the 90° column within the National Electrical Code. So in our case, when we're looking at that, you've got to understand that the ampacity values within the NEC are going to be higher on that table, and the UL only deals with the conductor size, okay? But you're still going to be protected. You're still going to be okay in the application. Now, let's take that one step further so you can kind of get a grip of that. So 250-122 said a 200 amp only needs a 6, right? All right, well then let's go now to 310-15B16. And we'll look at that real quick. And we'll look at that same requirement for that 3-aught. All right, now, here we are at 310-15B16. If you look at a 3-aught, it says it's good for 200 amperes. Under the 75 degree, we're fine. But when we're using 90-degree rated conductors, in the UL standard, we don't take into account anything about the overcurrent device or the woulda, the coulda, the shoulda. Here you'll see that under 90 degree, that same 3-aught is good for 225 amperes. Okay, so if it's good for 225 amperes, which exceeds 200 by obviously 25 amperes, that when you were to go back and see what you potentially, if I were to have a device that's rated for 90 degree, that didn't have the 80% factor on it, and maybe the terminals were rated for 90 degrees, then it could potentially connect to a 225 amp. That doesn't mean it's going to happen. Remember, the UL doesn't care about what the NEC does. It's the potential that it could happen. So, if it potentially could have 225 amperes on it, then we got to go all the way back and look at the requirements, the standard again, under, and I'm drawing a blank, what I was just at. Oh, 250.122. So we go back and look at that. And I got to run back and forth here. Sorry about that. All right. All right, now we're back at 250.122. The 200 would require a 6. But we just talked about the fact that it could terminate on a 225 amp overcurrent protected device. If that device was rated for 90 degrees C and it was rated for continuous use, there's so many variables in there. And the UL standard is trying to account for those variables. So under this case, if it was 225 amps, obviously it's higher than 200, but it is not over 300. So you have to go to the next one, and that would be a 4 copper. So because the 225 is greater than 200, and it is less than 300. So you want to use the larger conductor, and that would be the 4. And that's how the UL works. And you'll see that it kind of works. Now, if we only had 75 degree rated conductors, then it would work out fine. Then we would go to the 200, and that's what it would terminate on. And it would be a 6 gauge. And that's what you're going to see under the column 6.2 for the in the UL standard. Okay, for the 75 degree conductors. Clearly, I'm looking at it right here, and it says a 3-aught would only need a 6. And that would hold true here. So this kind of gives you the understanding that the UL doesn't care about the overcurrent device. The NEC cares about the overcurrent device. But there's enough fudge factor that's built into the UL standard to cover the intended use of the NEC. And that's what a lot of people lose sight of. Okay, so now let's talk about a parallel application and give you a scenario that we're talking about. All right, what if I have a MC cable with 3-aught copper in it, and we're doing it 90 degree rated insulated conductors in it. Okay, so it's rated 90 degree insulated conductors. And so, but we're using it as a condition of use. So now we're going to make the installation under the 75 degree terminal limitations of 110.14c. All right, we're practical, we're electrician, we're not worrying about the UL because we've already established that UL is going to make sure that that equipment grounding conductor is large enough for that single cable. Again, it doesn't deal with parallels. It's only dealing with that single cable. We're the ones that have to worry about the parallel application when we use the NEC. So let's worry about our installation here. I'm going to run, I got a 200 amps, I got a 400 amp service, but my choice is to run 2 parallel sets of MC cable with 3-aught copper in it. All right, so I were to go to 310-15B16, and I got to select a cable for that application, or basically a conductor for that application. So I'm going to do it now, and I'm going to look at it and say, all right, what do I need? All right, 75 degree terminal limitation. Again, because it's a cable, then I know that I got a certain number of conductors in there, so I don't have to worry about anything as far as the number of current carrying conductors in it in this scenario. I'm not going to assume any ambient adjustment or corrections, because at the end of the day, even if I did use 90 for adjustments and corrections, I still can't exceed the values of the 200 column, which is of the 75 degree column, which is 200 amps anyway. So even though I could use 225 for adjustment and corrections under 310-15B, 2A and 3A, I cannot exceed the values under the 75 because of my terminal limitations. And right now it's 200 amperes. But I need a 400 amp application. All right, so I'm going to run 2 parallel sets of 3/0 copper, and I go to the supply house. And the supply house is going to give me, for all intensive purposes, it's probably going to be 3/0 MC with a 4 equipment ground, okay, because it's 90-degree rated conductors in there. So it's a 4 equipment ground, all right? So now I'm going to start that. So now I'm going to run a parallel application. And under normal circumstances, if I was running that one piece of cable, it would be 200 amps, and I have a 200 amp overcurrent device. And when I go to the table 250.122 for a 200 amp, I really only need a 6, okay? But we put a 4 in there because of the minimum requirements, like we just talked about, that I could use it at 90 if the terminals and everything were rated for 90. So that's the fudge factor that UL's putting in there. But I'm using the NEC. So I buy it. It has a 4 in there, equipment ground. In my mind, I only needed a 6, but it's got a 4, and that's something that I can't control. That's part of the production because it's 90-degree rated conductors. Even though I'm going to use them at 75, I still got the 90-degree insulation. So that's what UL took care of. All right, so now I'm running them in parallel. Well, when I run these conductors in parallel, now I've got the application where now I've got a 400 amp overcurrent protected device ahead of it. And under a 400 amp overcurrent protected device, conditions change a little bit. And if you look under the 400, I got to have at least a 3 copper AWG for a 400 amp overcurrent device. So even the 4 is not large enough. If it was 300, it would be fine, but we went to a 400. So I have 2 3/0s in parallel, a 400 amp overcurrent protected device. I ran these conductors in parallel. Now what I've got is I've got 2 cables that only have a 4 equipment ground in it. It's not large enough. I can't blame the manufacturers because if I installed the 1 cable, it would be fine. But I installed them in parallel. Now my equipment ground is not large enough based on the NEC. So what do? I have to order specially an MC cable made with a 3 equipment ground, a number 3 or a 3 AWG copper equipment ground conductor in there in order to comply with 250.122. It's really that simple. Now, you can't buy an off-the-shelf MC cable in a 3/0 with a 3 equipment ground. You can't do it. You have to order it special. Now, maybe some companies would make it and have it sitting there in case you did a parallel, but that's not going to work because what if I parallel 3 together? If I parallel 3 3/0s, then I have the capacity to 600 amperes. And if I put that on a 600 amp overcurrent protected device, now my equipment grounds have to be a 1 AWG. So not even the 3 is going to work anymore. So that's not a manufacturer's issue. That's a in the field issue that you have to order a product for it if you want to use the cable. Now, if you pull raceways and you pull your own conductors, then you're pulling your own conductors. It's not an issue. But when you order a pre-made or pre-assembled type of cable, you have to understand that UL only governs the creation of that cable, not the parallel application. So you end up having to buy something special. Okay. So that's the issue with trying to explain the differences between a single cable under UL construction and parallel applications in the field. Okay. That's how it works. And hopefully I've been able to explain to you why you're not going to find the MC with the larger equipment grounding conductor unless you special order it. And that's the only thing to remember. Again, the key thing is UL specifications under 1569 have absolutely nothing to do with the NEC. And it doesn't have to. As a manufacturer, I don't have to comply with the NEC. It just so happens that if I follow the UL standard, I will comply with the NEC. And the UL standard will provide me a little bit of a fudge factor when it comes to potentially being used at the 90-degree rated insulated conductors at the 90-degree ampacity rating in 310/15B16. Even though I'm going to be limited to the 75-degree terminals, I could come into a situation where I use that cable with terminations that are rated at 90 degrees C. Then I have to have that same size equipment grounding conductor application. That's why UL does what they do. The NEC is different. Okay, so hopefully I explained it to you, give you a little insight on why it is what it is. And if you have any questions like normal, feel free to email us at info, that's INFO, at masterthenec.com. And I'm more than happy to answer any of your questions on this or any other topic that you would like to discuss. So thanks for listening. Everybody have a wonderful holiday, and we'll see you at the next episode of Master the NEC.